Hello, I'm Mohan Kelkar, and this is the third video of my video series on energy reality. In this video, I compare the fossil fuels with humans. Energy is important, but ultimately energy has to be used for useful work. Energy needs to be converted to useful work before it can become beneficial. It is impossible to use 100% of the energy for useful work. Some energy is lost in wasted heat or friction or in some other form. The percentage of the energy that can be used in useful work represents energy efficiency. So let us consider how we can use the energy in different ways. I have only provided few examples here, but you could come up with many examples where the energy can be used for doing useful work. For example, we use gasoline to move people from one place to another. We use natural gas to heat the houses during the winter time to keep the houses warm. Coal is used to run a steam engine or to generate electricity, which can be eventually used to lit a house. Big machines are used to move things around. There are many other applications and many other examples where energy can be used in a useful manner. Now let's contrast this to humans. Before fossil fuels, we of course use human energy, which was primarily used to get the work done. An average human consumes about 2,500 kilocalories. And out of those 2,500 kilocalories, 1,000 kilocalories are used for sustaining bodily functions, which cannot be converted to useful work. If a human does a physical work for about 8 hours in a day as a sustained effort, human will expend about 700 kilocalories in a day to do useful work. So the efficiency of a human is about 28%. That is, out of the 2,500 kilocalories consumed, 700 kilocalories are expended to do useful work. Humans also emit CO2 in the atmosphere. On an average, human emits about 2.2 pounds of CO2 per day. Humans will need also about 2,500 kilocalories as an input before human can expend 700 kilocalories in useful work. So those 2,500 kilocalories will have to be generated somehow, which human can consume before they can expend 700 kilocalories in useful work. Unlike humans, fossil fuels already have the energy stored. There is no need for an input of energy. Just like unlike humans, fossil fuels don't need an input in energy because that energy has already been stored through all the physical, chemical, and mechanical processes. Fossil fuels can be converted to useful work by various mechanisms, and the energy efficiency can vary over a wide range from as low as 25% for steam engine to as much as 90% for home heating furnace using natural gas. Just for convenience, we will use an average value of 50% to convert fossil fuels into useful work. This plot shows a comparison of 1 pound of fossil fuel with 1 human assuming a daily output. So for example, if we burn 1 pound of coal, 1 pound of oil, 1 pound of natural gas in one day, how much useful work can be done by fossil fuels? And we compare that value to humans. Now just remember that 1 pound of coal is approximately 3 inches of a cube of coal. So it's a very small amount. 1 pound of oil is only about 0.13 gallons. Again, a very small amount. So although the fossil fuel amount or volume is very small, they can generate significant amount of useful work for every pound compared to humans if we just consume that amount on a daily basis. The amount of CO2 emission by burning fossil fuels is also small compared to human. So if we assume that we have certain amount of coal, oil or natural gas is required to create 700 kilocalories of useful work, we know that human emits about 2.2 pounds of CO2 every day. How much CO2 will be generated by generating the same amount of useful work for coal, oil, or natural gas? And what you would observe is that coal will generate only about 1.5 pounds of CO2, oil will generate about 0.9 pound of CO2, and natural gas is about 0.75. So compared to natural gas and humans, you will find that natural gas will generate a very small amount of CO2 or carbon footprint compared to human. Now we have not included the amount of CO2 which is emitted because humans have to use an input of 2500 kilocalories to burn 700 kilocalories in useful work. If I include that, the CO2 which is emitted by human for carrying out work is significantly higher compared to fossil fuels. Here I compare humans with fossil fuels by assuming that the world population is 8 billion people and every one of those people will be working every day for 8 hours producing about 700 kilocalories per day worth of useful work for a whole year. Now I know that this assumption is not realistic. Perhaps only 15 to 20% of the people who will carry out such useful work, but let's consider the maximum effort humans can engage in. Assuming 50% efficiency, we can also convert the total fossil fuel consumption in 2019 and calculate how much energy will be expended in useful work. When you compare the maximum human effort with fossil fuels in this graph, you can very clearly see that the fossil fuel useful work is orders of magnitude greater than what humans can generate, even assuming that every human is engaged in doing useful work. What this graph indicates is that our civilization and the things we enjoy today are not based on human work, but it is really based on fossil fuels. Fossil fuels and the energy they provide create the type of comfort we have in our lives. You may argue that we don't want to use humans in the future. Instead, we want to use renewable energy such as wind and solar to replace fossil fuel. And that is true, but there are also some additional challenges using those energies compared to fossil fuel, as I will discuss later. Thank you for listening to this video. I hope you enjoyed it. Please subscribe the channel so that the next time a new video is released, you will know about it. Thank you.